or in this class, we will see or discuss Charles' law, that is the second law of the first topic of Form 3 class. In our last discussion, we have seen Boyle's law, whereby we have said Boyle's law deals the relationship between volume and pressure at a constant temperature. And we said it states that the volume of a given mass of a gas is inversely proportional to its pressure at a constant temperature. But for Charles' law, it deals the relationship between volume and temperature at a constant pressure. So it states that the volume of a given mass of a gas is directly proportional to its absolute temperature at a constant pressure. For Boyle's law, volume was inversely proportional to pressure, but Charles' law, it is the volume that is directly proportional to its absolute temperature, and the pressure is kept constant. So the law states the volume of a given mass of a gas is directly proportional to its absolute temperature at a constant pressure. So that is the state of Charles' law. The volume of a given mass of a gas is directly proportional to its absolute temperature at a constant pressure. So that means volume is directly proportional to temperature. So V is directly proportional to T, that is temperature. So that means if we introduce the constant K, that will be V is equal to KT. Well, that is the constant times the temperature. So that will be all over T over T. So V all over T is equal to constant K. So this means if the volume is directly proportional to temperature, that means if the volume is increased, the temperature will also increase because they are directly proportional to one another. And if the volume is decreased, the temperature will also decrease. So if the volume changes from V1, that is the first volume, to V2, which is the second volume, the temperature T will also change from T1 to T2. So this implies that V1 over T1 will be equals to V2 over T over T2. So that means if the volume changes from V1 to V2, the temperature will also change from T1 to T2. And this is the equation that we will use to calculate questions that are involving Charles law. So what is the difference between Charles law and Boyle's law? For Boyle's law, we said it deals relationship between volume and pressure. For Boyle's law, and this is Charles law. So for Boyle's law, it deals relationship between volume and pressure. For Charles law, deals the relationship between volume and temperature. Boyle's law, the temperature is kept constant. Temperature constant. And for Charles law, pressure is kept constant. Kept constant. Again, Boyle's law, volume is inversely proportional to pressure, while Charles law, volume is directly proportional to temperature. So those are the differences. Boyle's law deals relationship between volume and pressure. For Charles law, volume and temperature at a constant pressure, and for Boyle's law at a constant temperature. And V is inversely proportional to P for Boyle's law, and V is directly proportional to temperature for Charles law. So that is the difference between the two for Boyle's law and Charles law. So before we see the questions involving Charles law, let us see the interconversion between temperature in Kelvin and temperature in degrees Celsius, because our T here will be in Kelvin K. So interconversion from one scale to another. From one scale to another. So to convert temperature in degrees Celsius to Kelvin, to temperature in Kelvin, you add 273. And to convert temperature in Kelvin from Kelvin K to temperature in degrees Celsius, you subtract 273. So to convert from degrees Celsius add to Kelvin, add what? You add 273. For example, let's say here we have got 40 degrees Celsius, and this one is the one that we want to convert to temperature in Kelvin. So if you are converting from degrees Celsius to Kelvin K, you add 273. So that means now T capital, that is temperature in Kelvin K, will be small t, which is 40, small t plus 273. So T will be equals to 40 plus 273. That will be how much? That will be 313K. So that is how to convert from degrees Celsius to Kelvin K. And to convert from Kelvin to degrees Celsius, subtract 273. For example, here you have got, let's say, 25 K. This is your temperature in Kelvin K. So our small t, that is degrees Celsius, temperature in degrees Celsius will be equals to 273. Let's say here, let's have 400, for example, 400 K. So our small t will be equals to 400 minus 273. That is degrees Celsius in Kelvin minus 273. So that will be what? That will be 400 minus 273 is 127 degrees Celsius. So that is equal to 127 degrees Celsius. So that is how to convert from one scale to another, because what we'll be using in the calculation will be temperature in Kelvin K. And if you are given temperature in degrees Celsius and you need to calculate for a certain value, certain missing value, you need to convert that degrees Celsius to Kelvin K. So let us see one or two examples involving this law. Okay, here we have got an example. Example 1. Example 1 in this law. So a gas occupies a volume of 600 liters at 20 degrees Celsius. At 20 degrees Celsius. What will be the volume? What will be its volume? What will be its volume at 60 degrees Celsius? So that is our question. A gas occupies 600 liters at 20 degrees Celsius. What will be its volume at 60 degrees Celsius? So we will use our Charles law equation, that is V1 over T1 is equal to V2 over T2. So let us identify V1, V2, T1 and T2. So our V1 is equal to V1, we are given 600 liters. Again, V2, we are not given. That is what we need to find. And the T1, we are given 20 degrees Celsius. So that one, if we are given in degrees Celsius, we need to convert to Kelvin K. So our T1 will be equals to 20 degrees plus what? 273. So that will be 293 K. So our T1 is 293K. T2 is equal to, so T2 we're given 60 degrees Celsius. So that will be convert to Kelvin. So that will be 60 plus 273. That will be equals to what? 333 Kelvin. So now we have our V1, T1, and T2. So we can easily calculate V2. So we'll use our equation V1 over T1 is equal to V2 over T2. So our V1 is 600 liters, 600 liters over T1, which is 293, is equal to V2, which we don't have, all over T2, which is 333K. So from there, it is now easy to calculate V2. So we will cross multiple. That means 600 times 333 Kelvin all over 293K, equals to 293K times V. So that will be, so cross multiple, that will be 600 liters times 333 Kelvin will be equals to 293 times V2. 293K times V2 times V2. So to get V2, we divide 293 on this side and 293 on the other side. So cancel 293 with 293K. So here we are remaining now V2, on this side we have remained V2 is equal to 600 liter times 333K all over 293K. So let us cancel K with K. So we are remaining now with 600 liter, 600 times 333, divide that with 293. So that will be, so V2 is equal to 681.9 liters. So that is how we calculate V2 for that particular question. So let's see example 2, another example concerning the same law.